All right, so distributive property is something that you would have done last year. So it should be familiar, but we're going to do a bit of a different take on it. Hopefully that will help. Again, we've talked about this all along. It's all about strategies. Thinking strategies, solving strategies sometimes. This is kind of a thinking strategy, and it is something that you can come back to, and it kind of ties into what we were talking about yesterday with like terms. So just sit back and listen, but make sure that you are actually listening. Imagine you're going on a hiking trip with some friends, and you're in charge of snacks, and you decide to get everybody 1 apple, 2 bananas, and 3 bottles of water. And how many friends are you going with? 5 friends. So how many apples do you need?
5.
How many bananas do you need? 10, because 2 per person. For 5 people is 5 times 2, which is 10. How many bottles of water do you need? 15. Because 3 bottles of water per person times 5 is 15 bottles. That's distributive property, folks. You've got a bag full of 1 apple, 2 bananas, 3 waters, and then you're making up 5 of those bags. So everybody has a proper snack, lunch bag, whatever you want to call it. You got 5 of them. 5 groups of 1, 5 groups of 2, 5 groups of 3. So let's see how good I can draw this stuff. So this equals 5 apples, we have a brown, I'll use orange. 5 bananas, 5 pairs of bananas, like 5 times 2, right? And 5 bottles of water. If you don't want to draw these pictures, you don't have to do that. You can just watch. In order to make the bags, like if you go shopping, you're just going to buy 5 apples and 10 bananas and 15 bottles of water and then pack them into separate bags, right? That's what you're going to do. So that's 5 apples like we talked about. 10 bananas. And 15 bottles of water. How does that relate to what we're going to do? Because what we're going to do is with just variables and algebra. Look at, you need 1 apple, 2 bananas, 3 waters. So I need 5 of that, 5 of that, and 5 of that. But not 5 waters, 5 of 3 waters. So this you want to write down, 5 times 1a plus 5 times 2b plus 5 times 3w. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. So notice that I'm multiplying through the coefficients. 5 times the coefficient of a, which is 1a. 5 times the coefficient of b, which is 2, so 5 times 2 is 10, and then just b. 5 times 3, which is 15, and then w. Because what's the W? Well, that's waters. 15 waters. The variable is a thing. Okay? So this is the strategy that we use. But we're not always going to be talking about backpacks full of snacks. But you can use that as a strategy when we get to these questions. Okay, so now you're going on a hike with 2 friends. So there's 3 of you. And you've got 2 apples and 4 bananas per person. So if there's 3 of you and each person needs 2 apples, how many apples is that? 6 apples. There's 3 of you, everybody gets 4 bananas. How many bananas is that? 12. 3 times 4, right? 3 groups of 4. 4 bananas each. 4 and 4 and 4. That's what multiplication is. 4 bananas, 4 more bananas is 8, 4 more bananas is 12. 3 groups of 4 bananas. This is a strategy to understand what's happening here. But I think what you want to get used to is you take the thing out front and multiply through. Because the strategy works for these kinds of simple questions. But then when we start to get into some of the sort of more abstract ones with negatives and that kind of thing, the strategy of thinking about apples and bananas falls apart a little bit. But hopefully it's enough to kind of get us to the point where we remember that this is how you do distributive property. You take the thing out front and multiply it through by everything in the brackets. Stop at the end of the bracket. We'll see that in the next example. That's going to become important. So 3 times 2 is 6 apples. 3 times 4 is 12 bananas. Once again, if you want, you can use your calculator to do that work. 3 times 2, hopefully something we can do in our head. But the numbers will sometimes be less friendly, and you will need to use your calculator. So pull your calculator out to do that work. But notice that I don't put the A and the B into the calculator. It's just 3 times 2 and 3 times 4 that I put in. What kind of a snack would a D be? Doritos. That's what I was thinking too. What were you going to say? Huh? Donut. That's a good one too. I think I've used that in other years. For some reason, Doritos jumped in my head as well. Cupcakes for C?
I have another one. Dog food.
Dog food. Sure. Maybe you're going hiking with the dog. Dogs like to go for walks. And then G?
Grilled cheese.
Huh?
Grilled
Grilled
cheese.
cheese? 8 grilled cheeses? Oh my gosh, yeah.
Golden graham is cereal.
Golden grams. Oh, I used to love golden grams as a kid. Huh?
Gummies.
Gummies, that's a good one. Or grapes, maybe that's the one that comes to me. 8 grapes. That's not very many grapes, but yeah.
Or brownies.
Or what?
Brownies.
Brownies? That doesn't start with G, but you can think of whatever you want. You could still think of apples and bananas and water or whatever you want. Obviously, granola bars, that would be appropriate for hiking. So anyway, 3 of something, 2 of something, and 8 of something. But then you're doing 5 of each. So 5 groups of 3 is 15. So 15 donuts or 15, I don't know, Doritos or bags of Doritos. 15 Doritos isn't that much. Carrots maybe, C is carrots. 2 carrots per person, 5 people, 10 carrots. 8 grapes per person, 5 people. Again, you're just multiplying each of them. Remember, a number beside brackets means multiply. So when you look at that, you should just recognize that it means multiply, but it means you're multiplying everything in the brackets. You have 5 groups of the brackets. What's the bracket? It's your backpack or it's your lunch bag. This is your strategy, that the brackets are representative of that group of things. And you have 5 of them. So I have 5 of each of the things in there. 5 times 8 is 40. Whoops, 40. Good. Okay. Whoa, what happened? What's going on? muffins and Pop-Tarts. Maybe this is a breakfast thing. I don't know. If it helps you to think about the M as a thing, like that to me is a good strategy. If in your head you're always kind of thinking like, what could M be? It could be a muffin. What could P be? It could be a Pop-Tart. It could be a pop. Whatever you want, but it's a thing. I got 6 of them, I got 5 of them, and I'm doubling them both. So what happens if I double 5? What happens if I double 6? So give this one a try on your own. $10M plus 12P, is that what you got? Awesome. Try the next one. Six times 5.
When there's nothing but just a letter, there's no number, does that mean it's 0?
No, it means 1. Which question are you looking at? E?
E, yeah.
Okay, so give me a second. We'll be there in a second. 6 times 5. Good, 30. So 30x. I cannot think of a food that starts with X, but I don't know, xylophones. That's always the one to go to, right? Huh? Zebra cakes. 6 times 2. 12. Okay. And then, yeah, this one, so 4 times 2 and 4 times -1. So then we're bringing integers back into it. You do have to think about the sign.
I got something for nuggets.
Nuggets, yeah. Good. And Triscuits?
Tall grass.
Tall grass. But this is where it starts to get a little weird because 4 times 2 is 8. 4 times -1. So I got 8 N's, 8 nuggets. That's -4. So what does it mean to have -4 tall grasses? You owe somebody else 4 tall grass. Doesn't really make sense, but that's okay. Hopefully, like I said, we start to understand what's really happening here at a more abstract level. And we don't have to worry too much about how it actually applies to the real world, but we're incorporating our understanding of integers, but then thinking about the t as a thing or the n as a thing or whatever, right? Okay? One more? Give this one a try. What's different about this one from all the other ones? Yeah, 1 doesn't have a variable. That's okay. You just multiply 2 times -9, -18 to get your answer. That's all. Okay. So you could still think of it as a thing, bananas or whatever you want. Like that's up to you. But that's your constant. Remember we talked about that before. And you're still just multiplying. 2 5x's and 2 -9's. Okay. What's different about example 2? Yeah, it's a bigger question. There's 2 brackets, and notice it says expand and simplify. So here's the trick. I just want you to watch for a second. This 2 means I have 2 groups of that bracket. That's what it means. So I have 2 of this and 2 of this. What do you think somebody might do at making a mistake in a question like this? Yeah, keep going like, well, let me do that in a different color because it's wrong. By that, by that, by that. What do I keep doing? Go on to this one and onto this one to the next question. Like, well, how far are you going to go? This means if we go back to our backpack idea, right? Analogy, this bracket, this first bracket is my backpack. I've got 2 of that backpack and I've got 3 of that backpack because maybe somebody else likes different snacks. So I got 3 of this and 2 of this. So you have to stop multiplying at the second bracket. You stop multiplying by the 2. But then this 3 does get multiplied into that one because I have 3 groups of that bracket.
I found a food that starts with an X.
What? Did you Google it?
Yes.
Okay, what is it?
Oi.
What's that?
I don't know how to say it. It's X, funny O-I.
Interesting. Does it say what it is though?
Sweet sticky rice.
Ah.
Vietnamese breakfast.
Oh. Sounds good. All right, so 2 times x is 2x. 2 times 3y is 2 times 3 is 6, so 6y. Stop multiplying. 3 times 2x is 6x. 3 times y is 3y. Let's just keep it simple. Let's say x is apples, y is bananas. So 2 people are getting 1 apple and 3 bananas, and 3 people are getting 2 apples and 1 banana. That's what they ordered. I don't know. Still going on a hike.
6 yogurts.
Sure. Yeah, yogurt. That's a good one. When you go shopping, you don't shop for everything separately. How many apples are you going to buy? 8 apples. Because you need 2 for the one kind of backpack and 6 for the other kind of backpack. So you're going to buy 8 total. This is where what we were doing yesterday, where we were regrouping 2 apples and 6 apples, and 6 yogurts and 3 yogurts. And I add those together, and I add those together, and when I go shopping, I get 8 apples and 9 yogurts. And then when I get home, I split them up into their backpacks or whatever, but that obviously that's not math class related, but right, that's the idea. But if you went shopping, you just need to know how many total yogurts do you have to buy to pack the lunch bags. How many people pack their own lunch? Or your parents pack your lunch for you still?
I used to. I don't have to lunch.
Now you just don't take a lunch?
I have a question.
Yeah.
I buy my own lunch. What would that fall into?
That would fall into you're taking care of yourself,
Alright.
I would say. I just like, if you're in a household where there's 3 or 4 kids and you're packing lunches for everybody in the morning, like I still pack lunches for my kids, and you're packing lunches for them, you might need 2 yogurts and 5 apples and right, like that kind of thing. Okay, one more. Do you want to try this one on your own?
Yes.
Excuse me.
And then stop. Okay, and you can check your answer. So the big takeaway is distributive property when you've got a number outside a set of brackets, and inside the brackets you got variables added together or whatever it is. And how do you expand that? Multiplying through. But then the other one that we did, the other kind of example that we did is where you expand and then including what we did yesterday, you simplify by collecting like terms. And remember, it's the same thing as yesterday. Why do you simplify? Because I wouldn't go buy 3 apples, 3 bananas, then 6 more apples and 2 more bananas. I would just get 9 apples and 5 bananas. Right? And then split them up accordingly, I suppose. So when you have an exponent like this, I'm still multiplying through, so the strategy doesn't change. And this one's a little bit different as well, because there's no number, but there's just a negative. So what does that mean, negative? Negative 1, right? So it's like there's an invisible 1 there. So what's the coefficient of the x squared term? Same thing, it's 1. 2 times 1 is 2. 2 times negative 3 is negative 6x. 2 times 4 is 8. Notice I'm not really thinking about that strategy anymore because now I'm just getting used to the idea of multiplying through the brackets and just doing distributive property. This is negative 1 times 1x, so negative 1x or negative x, and negative 1 times 3, which is minus 3. And we talked about this yesterday. I've got x's all over the place, but is x squared the same as x? Are they like terms? They are not like terms, so you cannot add them together. So I've got one x squared term. I've got 2x terms. And I've got 2 constants. Squared, thank you. Yeah. So 2x squared, negative 6 minus 1. Negative 7. Watch, folks. Negative 6 minus 1. Negative 7. If you're struggle a bit with integers, use your calculator. 8 minus 3, 5. Does that make sense? Okay. Okay, so that one has a squared. It also has constant, so a little bit different from the other ones that we saw. And, you know, you could have 2 brackets that both have an x squared term, and again, you would add them together. They would be like terms, x squared, 2x squared and 3x squared would give you 5x squared, right? But you don't add it to x. X is a different thing. Again, this is where that analogy of like foods kind of falls apart, because what's a food squared? Well, it doesn't really make sense, but they would be just 2 different kinds of food. So you can't add them together. So you could still think of this as apples, bananas, and grapes or something like that, right? 3 different kinds of food, and you can add the ones that are like each other together.